This is lesson 4.3, solving polynomial inequalities. A polynomial inequality is an inequality that contains polynomial equations. In order to solve polynomial inequalities, the corresponding polynomial equation must be solved first by determining the root of the equation. So basically, before we solve any inequality, we have to first look at this inequality as an equality. So instead of writing bigger or equal to or less or equal to, we write equal to and solve for the root. Once the root has been determined, then determine the sign of the polynomial in each of the intervals created by these roots. And we'll go through all of the steps in today's lecture. So let's take a look at example 1 from your learning resources. It says to solve the following and graph it on the number line. Let h of x be x squared minus 4x plus 3. Solve for h of x less than 0. So in step 1, we have to solve it like it's an equality. We have to make it equal to 0 rather than less than 0. What we get from this is the root. So we factor the equation out, and that will give us x minus 3 times in bracket x minus 1 equal to 0. We can clearly see that x equals to 3 or x equals to 1. On the number line, it will look something like this, where 1 and 3 are filled because they are the roots and they are contained in the equation. Now let's split the number into 3 sections. One section is x less than 1, one is less than x less than 3, and one is x bigger than 3. We know that at x equals to 1 and x equal to 3, h of x equals to 0. So at step 4, using any number within these intervals to see if they hold true for x squared minus 4x plus 3 less than 0. For the interval of x less than 1, the value is 3. If we use x is equal to 0 and 0 is less than 1, so 0 holds. For 1 is less than x, less than 3, let's use x equals to 2, and that will give us the value of negative 5 for h of x. Let's use x equals to 5 for the interval of x bigger than 3 because 5 is bigger than 3. We get a value of 8. But remember, in the original equation, it asked us to find h of x such that h of x has to be less than 0. Is 3 less than 0? Well, absolutely not. Negative 5 is, so yes. 8 is not. So we see that only the first interval holds for only the interval of x is less than 3 but bigger than 1 holds for h of x is less than 0. So in step 5, we have to indicate which interval holds true for the polynomial inequality. Therefore, the number line should be like so, where 1 and 3 are not included because they are the roots, but they're not included in the inequality. But everything that's bigger than 1 and less than 3 is. And that's drawn here by the bolded line. If the original inequality was bigger than 0 and not less than 0, then the number line would be something like this, where everything that's bigger than 3 would be true and everything that's less than 1 would be true. 3 and 1 are not included because they're the roots. Which makes sense when you graph it like this. So when you want h of x is less than 0, you want this area, which is the area that's underneath the x-axis. And when you want h of x is bigger than 0, you want this area and this area. That's the end of this lecture, and please remember to do your activity videos and as well as your assignments, and I'll see you